Hello everybody. In today's lesson, we're going to talk about geometric sequences. We've covered it a little bit yesterday. We're going to do more problems. So let's get started. Yesterday, we talked about what a common ratio is. Basically, it's a number you use to multiply to get to the next number. And then you use that same common ratio number to multiply to get to the next number, and the next number, and the next number. If you don't know what the common ratio is, you can just really quickly do second number divided by the first number and you'll see it. And just test it out. Do the third number divided by the second number to make sure that the common ratio is the same. So let's go ahead and look at example 1 to see what the common ratio is. It's asking for the r. So a quick way is just to do r equals the second number divided by the first number, which reduces to 1/2. I am going to check to see if that's the case for the next one. So I'm going to do r equals the third number divided by the second number, and that's 0. Since the r numbers are not the same, I could say that r does not exist because the sequence that they gave us is not geometric. Okay, so this one is not geometric because you're not multiplying by the same number to get to the next one. All right, let's look at example 2. In example 2, they're giving us values again, so I'm just going to try to find the r number. Second number divided by 2, that's 3. I want to do the same thing again. Third number divided by the second number, that's 3 as well. That's a good sign. Let's try that one more time. What about 54 divided by 18? Is that 3 as well? And that is 3. So since all of the common ratios are 3, that means it's common. And the common ratio is 3, and that sequence is geometric. All right, let's look at the next one. It says here, decide whether each sequence is geometric. Show verification by showing that all the common ratios are the same. So we're going to do the same thing that we just did in the problems above. So I'm going to try to figure out what the common ratio is by doing the second number divided by the first number. And 6 divided by 3 is 2. And I'm also going to do the third number divided by the second number, which is 3. Now, since these are not the same number, we can say the following. The sequence that we have right now is not geometric. And if they asked us why, we would say it's because it does not have a common ratio. It's not common if one is being multiplied by 2 and the other one is being multiplied by 3. All right, so we don't even have to test 18 divided by 54 if two of them are already different. All right. Let's go ahead and look at the next one. So we have r equals the second number divided by the first number. Well, that's 5. We're going to do the same thing. The third number divided by the second number, and that's 5. And we're going to do the fourth number, negative 250, divided by the third number, and that's also positive 5. Since they are all the same, that means that the sequence is geometric with a common ratio of 5. It means that every number is being multiplied by 5 to get to the next number. So that would be our proof and our statement. All right. So today we're going to do a little bit of work. We're going to talk about ratios much more than in previous lessons. We're going to solve for different components of the equations. Let's really quickly share. So this equation is only used if it's geometric. If it's not geometric, I cannot use it. So this is a geometric formula. And A1 in the formula is once again the first term in the sequence. It's the first number. N is the number of terms, so they'll say, I want the 7th number, and that would be n equals 7. And then R is, once again, our common ratio. Okay? All right, so let's go to the other page. All right, so let's use some of these. It says write the rule for the nth term of the geometric sequence. In other words, the formula for an, and then find the term given. Okay, so what we're going to do is they're going to give us a statement and they want us to find the nth term. So let's talk about, so they want us to find a sub 9, really. That's what they want us to find. And n in this case is 9. It's a sneaky way of telling us because they want the 9th number. And A1 is the first number in the sequence, and that is 3. And R is the common ratio. So I'm going to calculate R really quick. I could tell what it is, but I just want to make sure it's 6 divided by 3. That's 2. And so that's multiplied by 2 is 6. 6 multiplied by 2 is 12. 12 multiplied by 2 is 24. So the common ratio is 2, and it works. And then what we're going to do is use the formula. The formula we have is AN equals A1 times R to the n minus 1. Well, AN is A sub 9, and A1 is 3, and R is 2, and then we have 9 minus 1 power. And I'm going to go ahead and substitute that into the calculator to see what my value is. All right, let me see. Let's get our calculator out. All right, just the only thing I need you to be careful with is please do not multiply the 3 times 2. Leave them alone. So it's going to be 3 times 2 to the, let's see, 9 minus 1, so 8 power. That's what it's going to look like. So we have 768 is our final answer. So we have 768. All right. So let's keep going. Now here it says, once again, find the 10th term. So we're going to go ahead and find A sub 10. And n is going to equal 10 again because they want us to find the 10th number. A1 is the first term, that's 8. And we want to figure out what the common ratio is. So I'm going to just do 12 divided by 8. 12 divided by 8, they have a 4 in common, so that's 3 halves. And I want to know if that's true for the other ones. So if I multiply this by 3 halves, I get 12. Do I get that when I multiply 12 by 3 halves? And I'm just going to double check that. 12 times 3 halves. Yep, that's 18. And then I'm going to multiply that by 3 halves again to see if I'm going to get the next number, which is 27. So let's see. Yep, that's 27. Awesome. So I know that's the common ratio. I just wanted to double check it because if one of them is wrong, then the whole thing is, I can't even use the formula. So we have A sub n equals A1 times R to the n minus 1, and we're going to substitute everything we know. So A sub 10 equals A1 is 8, R is 3 halves, and n is 10 minus 1. I just do 10 minus 1 in my head and remember that that's a 9. So that way when I substitute it in, I know what my answer is going to be. All right, so I'm going to do 8 times, now since it's 3 halves is a fraction, I'm going to put it in parentheses, raised to the power of, I already forgot, 9. 10 minus 1. Okay, so we have this. Now I'm going to see if I can make it a fraction. And I can. So I'll write the fraction form, 19,683 divided by 64. So 19,683 divided by 80, was it 84? 64. There we go. Okay, and that also goes here, just so that we have nice notes. All right, well done. All right, let's look at the last example that we have. It says find the 20th term. So we want to look for A sub 20. N equals, once again, 20 because we want the 20th number. A1 in this case is 1. And R, it looks like it's being multiplied by negative 2, but let's test it out. Negative 2 divided by 1 is negative 2. Is that true for the second one? Negative 2 times negative 2 is 4, and 4 times negative 2 is negative 8. So R is negative 2. And then we're going to go ahead and sub it in to our formula. And we have A sub 20 equals A1, which is 1, R, which is negative 2, and it's 20 minus 1 power. So we're going to go ahead and substitute that in to see what A sub 20 is. All right, so we have 1 times negative 2 raised to the 19th power. Whoa. Okay. So 524, negative 524,288. Negative 524,288. We'll put that in both places, and that is all for today's lesson. Okay, so I hope that was helpful, just finding geometric sequence. We're spending one more day on these concepts. Well done, okay, and I will see you in class. Bye.